SI.
Hi, Sai. So you're on
Oh,
mute.
sorry. Yeah. Hi, Srinivas. Hi, Senthil.
It's been almost 10 days, I guess. Okay. So let's see the next algorithm, and then a random forest classification. Okay, so I think we have already seen about many things.
We seen in what is that? Mm,
Regression, random
regression.
forest
Random
regression.
forest regression.
Yes.
And that means the algorithm looks like similar, correct?
Similar, similar. Yes.
So
I think if you open up the random forest classification code, you can see, I mean, the basic stuff like importing libraries, importing datasets,
mm,
and
mm,
training and testing, and during the similar process, how we have passed like an SVM decision tree.
mm,
If the decision tree doesn't, come under, if it is slightly overwhelming or overfitting, then it is obviously, confined to get into the random forest. So that is what the information we are getting, and the future scaling. In future scaling, we are just standardizing the data set, the information which we are getting, and then during the classification, I mean, yeah, classification of decision tree. Yes, you can see random forest classifier.
mm,
So there is, ensemble. The word is really attracting word. It's called ensemble model. We'll see what is ensemble, and then in random forest classifier, how we are classifying based on the number of estimators, n equal n underscore estimators equal to 10. And how do we decide number of estimators? That is, how we did estimate, like, what is the value for k. The same kind of thing, in estimators. This is also an important criteria. And then the criterion equal to entropy. Entropy model we have already seen in the session tree, so that we already know the entropy. There are a lot of entropy models out there, and random underscore state. How we are randomizing the iteration process, everything. So here, the ensemble model is very new, and the other processes like predicting a new result, and how we are validating the new result using the confusion matrix, and everything else, it is similar to what we have done so far. But there is one slight change and slight informational change, and also how the ensemble model works. So ensemble, it's a key in a random forest classification. So how does it work? So it's okay. Mute medium dot. Okay, so what are all, I mean, before processing the this kind of a classification model, what would be the assumptions? Why we are going for this model based on the pre-processing? See, what I would suggest, even each and every step of the information you are getting, okay, while importing, and then importing the data sets, while pre-processing data set, there itself, we just try to visualize the information, like how we are doing after the, applying the model. So the best practice is, please try to visualize the data sets, so that okay, this would be the, this might be the perfect model. And that decision making is very, very important for every machine learning engineer or machine learning developer. So that means you might know the flow of data, and you might know the distribution of data sets, distribution of information, so that you'll be able to make a decision on the spot. Otherwise, you have to go and do the say for instance, you are working in an environment, live environment. You are working for a company as a machine learning engineer, and you are getting the data set. Okay. Um, you have the limited time, time period to do this kind of a task. And what you do, uh, I mean, there are two or three methods of working methodology in any machine learning engineering environment. So in few method, you will be getting, okay, just to test all these kind of a basic machine learning processes for a accuracy. That is one method. The second method is come to a decision point, which method you would be you are going to recommend. Okay, based on the accuracy. The third method is it is up to you. You just decide and come back to me, come back to us. So these are all the three ideology, because see, data set is ultimate point of decision making, because the huge volume of data we are going to deal with. So you never know that which environment you will be in. You have to be ready for all these three environments. So in that case, you have to make a visualization during the, I mean, after the pre-processing itself, so that you might know, okay, this is how the flow, I mean, data flow and data distribution, so that I will select this model, or at least I will select um, two or three models, so that you will come to a decision point very soon. So that is also one of the points I think I was reiterating in our during the class, during the sessions, but still I want to reinforce the lesson. Okay. So the independence of trees, a decision trees in the forest should be independent of each other. This is achieved through bootstrap sampling and feature randomness. So randomness, feature selection, right? So the decision tree always independent of trees and sufficient data. Random forest requires a large amount of data, obviously. It is not like a decision tree or any other basic machine learning. Random forest, it will be just assume the real forest and how you are randomly searching for any classification of trees. Similar live example, it is also there in this sampling. Okay, so when it comes to a data point, you will be dealing, I mean, you will be required to deal with a huge or large amount of data set to build diverse trees and achieve optimal performance. So otherwise, you won't get the optimization or optimal performance of your model. Balanced trees, the algorithm assumes that the individual trees are grown sufficiently deep to capture the underlying patterns in the data. So we need to identify which, what kind of a pattern the data set is, so that we can remove it, some of the noisy data, and maybe the outliers data, so that the trees get balanced. So noisy data handling is, it can handle noisy data, but it assumes that the noise is randomly distributed and not systematic. So randomly distributed, like if you see this graph, okay, this is one of the random forest classification models, and maybe it is all the outliers or other the information, the unwanted information, which is there in the green part, right? In green you can see some of the red. These are all the outliers, and it is randomly distributed, and you can't do anything, and you don't want to do anything. You don't want to delete, and you don't. I mean, just see the distribution. That's it. That's enough. So that's what they're saying. So, but it assumes that the noise is randomly distributed and not systematic approach. It doesn't have any kind of a pattern or a system to follow. So if it is like this, then your assumption of a random forest model, that is good. That is what I would say. Uh, After the pre-processing data, you can just go for um, visualization. Okay. Random forest, a popular, I think we know, but still we just recapture. Merges the outputs of numerous decision trees to produce a single outcome. Okay, so it has been developed by this guy, Leo Bremen and Adley Cutler. Okay, so merges the outputs of numerous decision trees, because in decision tree, during the decision tree process, it cannot be controlled by the decision tree algorithm. That is why we are dealing with random forest. So those numerous decision trees, it will just merges together and it produces a single outcome. So its property stems from its user friendliness, versatility, making it suitable for both classification and regression. Mostly, it is for classification purposes. Okay. And one of the most important features of the random forest is that it can handle the dataset containing, you might know this, right? So it is a continuous variables, as in the case of regression, it is a categorical variable. So as in the case of classification, it is a mostly wider options for categorical variables. That is the importance of the classification. Okay, yes or no, true or false, and male or female, or whatever the case might be. This is a basic to understand, make it understand. We are using yes or no, those kind of Boolean values. But other than that, there are so many things to be categorized. Right? If you see the data set, then you might know, because we are going to deal with a lot of textual data, textual information, and not only social media platform data. There are so many other things we are going to deal with. So the mainly on classification of categorical variables. So it performs better for classification and also regression, but mostly classification. Okay, so what all the application we'll see later. Let's see how the analysis would be. Okay. So the real life example, I think in regression we have seen, but it is a different. Let's see. I think we have seen at that point. Let's say recap. A student named X wants to choose a course after his plus two, and he can't decide which course fit for his skill set. So he decides to consult various people like this, who this is successors or predecessors or peer group or a lot of reasons. So he asked them varied questions like why he should choose job opportunities with that course and course fee. So there are so many criteria. And finally, after consulting various people about the course, and he decides to take the course suggested by most people. Okay, so this is one of the classic use case to use the random forest algorithm. So various people act as an individual decisions, and that is also one of the decision tree. Questions asked by him perform the activity of decision tree, and the final decision acts as a final output based on majority voting. So it always, it seems that we are taking our own or final decision. Actually, if you just take it for consideration, it is always majority of the informations are voting you are getting, then that is the maximum advantages and also the disadvantages you are considering, and then you are going to make a decision. Maybe right from your after plus two, this applies. And after choosing your course, and then how did you study and how did you choose your higher studies, and then how did you choose your career? Those things also, you are taking a decision, and based on the peer group achievements, and you are also taking the decision. Then how did you take the decision of becoming a SAS programmer? That is also one of the use case for random forest. Okay. So the majority of voting, that means, I mean, we thought that we have made a decision. No, there are so many other reasons. Maybe, you go back and, give out the reasons, write down the reasons, the reasons, if you just, analyze the reasons, um, that, many reasons would just, favor in terms of what you have decided. Okay, so that means many people, got influenced, your thought process, and then you made a final decision. So that decision trees, each and every decision tree would be the decision point, but still, it just, you made some decision because of majority of decision trees, voting. Then you made a decision, and you can take it for any exam, not only your career or I mean, after, I mean, only the career part. If you even, take your home, if you are discussing something, if you are going for a movie, right? It's a weekend movie. If you are going, if you are planning to go, then how do you decide based on whose preferences? So those kind of things is also, coming under this kind of things, right? So just, yeah, this is the bagging technique, and this is the parallel technique. So we'll be seeing bagging and boosting would be the two methods of uh, decision making process. And this bagging and boosting we just touched, I guess, and we didn't discuss in detail. So we'll be discussing now. Okay. Okay. So we must look into ensemble learning techniques. That is what, we started with. So ensemble simply means combining multiple models. So thus a collection of models is used to make predictions rather than an individual model. So from this model onwards, you will be seeing the collection of algorithms. I mean, the collective effort of algorithms, so that a single model or a single output, you will be getting it very, very fast, and that model will be the ultimate power of, getting you the more accuracy. That is also there. Okay, so especially in random forest, that is why it is just, standing out from any other algorithm. It is because of the combining multiple models. We'll see. Okay, so how it is combining multiple models and why they are calling it as multiple models. Maybe they have not given the name of models, but the process itself it's a model. Okay, right. So here are two methods, right, to make a prediction. One is bagging and one is boosting. So the bagging technique, it is a parallel process. It is a straightaway process, right? And boosting technique, it's a sequential process. If it starts from one end, it is just, go in a sequential order. It doesn't, affect anything. It doesn't um, block anything. It is a sequential order. Whereas the bagging technique, it's a parallel process. If you just stop anywhere, still the bagging methodology will work. Not like, boosting. Boosting, it is a sequential order. It is going in an order. If it is not in order, then you have to apply the bagging technique only. So there is no other way. Okay, let's see one by one. So what is bagging? It is a bootstrap aggregation, serves as the ensemble technique. And what is bootstrap aggregation? We have to, know that. What is bootstrap aggregation? Okay, so bootstrap aggregation, also known as bagging, is a key technique. So bootstrap aggregation is nothing but the bagging technique. That technique, you know, I mean, why it is called as a bootstrap and why we are just naming it a bagging technique. So it is a technique used in random forest to, to improve the accuracy and robustness of the model. So bootstrap sampling from the original training dataset, multiple random samples are drawn with replacements. So this means that some data points may appear multiple times in a single sample, while others may be excluded. These random samples are called bootstrap samples. Please observe what they are telling. From the original training dataset, multiple random samples are drawn with a replacement. So this means that some data points may appear multiple times in a single sample, while others may be excluded. So we'll see with the examples. Okay, so why, how, I mean, what would be the right examples to understand the bootstrap sampling so that we will get some visualization. Okay, so you might be getting repeated information. It might look like, the similar kind of information. Right? See, it might look like, I mean, in the training data set, I think
Yeah,
it is getting
suddenly.
repeated. Yeah, this is what it is. This is the visualization of Bootstrap. Okay, in the training data set. So this is how we have to interpret the image. This is the one. Next, a decision tree or a classifier is trained on each of the Bootstrap samples. Since each sample is slightly different, each tree will learn slightly different patterns or decision rules. So this is how the model is getting trained. So each and I mean that is why now we are calling it as a collection of models, because each and I mean bootstrap sampling is one model, and how the model is getting trained, and each and every stage it is getting trained on each of the bootstrap samples. Since each sample is slightly different, each sample is slightly different. Each tree will learn slightly different patterns of decision rules. This is one of the second model. The third model, aggregation. So once all the decision trees are trained, they are combined to form a random forest, right? That is why it is a collection of all these three rules, and that is nothing but models. And for classification tasks, the final prediction for a given input is made by taking a majority vote across. This is what we have seen. So let's see. Before going and see the benefits, see the real life. Uh, medical diagnosis, right? Problem, predict whether a patient has a certain disease, example, diabetes or heart disease, based on medical records and test results. How bagging helps. So multiple decision trees are trained on different subsets of the patient's medical data, age, symptoms, test results. So each tree might focus on different aspects such as blood sugar levels or family history to make its prediction. When aggregated together, the majority vote across trees gives a more reliable diagnosis, reducing the chances of misdiagnosis due to noisy data or outliers in any single patient's record. I think you'll be able to visualize how this will affect the decision making. So the outcome, more accurate predictions of diseases, which help doctors provide early intervention, resulting in better patient outcomes. So that if it is any kind of life-threatening diseases like cancer or something, right? we will be able to identify in early stage itself, and then we'll just try to cure that. This is one of the example. Credit scoring predict whether a person should be approved for a loan based on their financial history. There could be multiple reasons, multiple ensemble methodologies. And this is where the word is coming into place. The credit score, income, loan history, and everything, right? So each tree is trained on a different random subset of the customer's financial data. Some trees may focus more on credit score, while others might focus more on loan repayment history or income stability. Right. So by aggregating these trees, random forest reduces the risk of any single tree making on an overly optimistic or overly pessimistic decision. So banks can better identify low risk customers for loans, reducing loan defaults and improving profitability. So if you are taking constantly a personal loan or a housing loan or a credit card, you might know. I think you have enough experience. If would have used all these, products. Okay, so you'll be able to relate. Spam detection. Classify whether an incoming email is spam or not based on features like email content, sender, subject, and metadata. Okay, different decision trees might focus. So this is where our Gmail will just more focusing on the multiple checkpoints, multiple decision trees, and that's how what we have seen in our right Gmail in primary promotions in social, and then in spam. There are so many categories nowadays. There are so many things have been improved based on this. Okay, so random forest background techniques. And then, yeah, more accurately classify spam and non-spam emails, ensuring users don't miss important messages. Fraud detection in banking, yes, obviously. And then product recommendation systems recommend products to customers based on their past browsing and purchase behavior. Different trees can be trained on different subsets and how they are using the past purchases, items viewed or searches. One tree might prioritize browsing history, while another see. I think in each and every model, you will be getting more advanced techniques, right from your simple linear regression models. If you are coming to the latest, the classification models, you can see the difference. You might be knowing that each and every model will be using the same, the same kind of a problem statement, right? It might look like similar, but if you just come across each and every problem statement, then there's a slight variation and difference between the basic machine learning regression models and slight advanced classification models. Okay, so might be useful for many use cases. So customers receive more personalized and accurate product recommendations, leading to higher satisfaction and increased sales for e-commerce platforms. So if you see any kind of e-commerce portal, okay, so all these right from basic machine learning, recommendation engine until the using the LLM, you will be getting the recommendation system. So they won't neglect or they won't remove any basic idea of satisfying the customer. So if you closely watch and if you closely observe, you will be seeing the differentiation. What I'm just telling. So they won't only focus on the advanced machine learning concepts. They also focus on the basic machine learning concepts like this. Sentiment analysis for product reviews, how the sentiment it is going in the positive direction or if it is going in the negative direction. How we are making out for deciding even for a single and even for a 10 rupee product, right? It applies for a 10 lakhs product. So everything based on the reviews, based on the sentiment. How is it worth investing on these products. That is where you come to a conclusion. And then image classification. Classify different objects in an image. A self-driving car detecting pedestrians, stop signs, or other vehicles. So each and every step, this basic uh, classification is required, or this can be implemented in an advanced computer vision technology too. The similar kind of a classification, because it has to classify and it has to identify, it has to make a decision on the spot like a human being, right? So this is where the bagging technique helps. And what is the advanced here? So it reduces the overfitting, increases accuracy and stability and robustness. Okay, so let's again come back to this. Yeah. Selection of subset, bootstrap sampling, bootstrapping, independent model training, majority voting, and aggregation. Just to see the graph, I mean the visualization, the infographics, and how the ensemble classifier, it is just making a more decision. Okay. So this is the original data, and after that, it is just trying to classify, right? And then we are applying the bagging. Example, by breaking it down with the help of following figure. Here, I just see the visualization. So this is the actual data. This is a bootstrap with all these, color differentiation, and then model 1, 2, 3, and then you can just, decide what kind of recommendations. So based on the majority voting, see these two are just imply one emotions, and based on that, this model is able to decide. Okay, this is how it simply works. Okay, so boosting, so bagging, this is how it works. How this boosting is one of the techniques that use concept of ensemble learning, the same kind of a learning methodology, but boosting algorithm combines multiple simple models, also known as weak learners or base estimators, to generate the final output. So it is done by building a model by using weak models in series. Let's see one by one. In boosting techniques, you will be, getting the variety of, boosting techniques. Unlike the bagging technique, bagging it's very parallel process, but boosting is a sequential process. You will be dealing with a lot of methodologies like GBM, XGBoost, Light GBM, and CAD Boost, and there are so many other boosting techniques. Boosting is nothing but it boosts the weaker elements for standardization or getting the accuracy. How this ensemble model will select the boosting techniques and which model would be appropriate. That is based on our experience. I mean, the machine learning engineers or machine learning developers' experience. So that is also always based on the number of estimators. That's what we have already seen in our code. So let's see, one by one after discussing this. Okay. So what are the process? There are several boosting algorithms. Adobe Boost was the first really successful boosting algorithm that was developed for the purpose of binary classification. Adobe Boost is only for the binary classification, it's nothing else. And also, it's an abbreviation for adaptive boosting, adaptive learning. The same, I think adaptive learning I have explained uh, 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 maybe in our during the course of time. Still, maybe Senthil will have a different a kind of a learning methodology. I mean, if we wanted to uh, test it out, I mean, if he is preparing for any kind of a competitive exams, Senthil will follow a different methodology. Sai will follow a different methodology. methodology, and I will follow my own methodology. Okay. And the model of adaptive learning, there is a framework. Just assume, X is a framework. Okay. So this framework you are using, Sindhili is using, Sai is using, and I'm also using. Okay. This adaptive learning, what it will just learn, it learns my behavior first. So that that means what is my level of competency, what is my potential, what is my behavior of answering any kind of a test, and what all the things I'm taken into consideration. So based on that, my text, I mean, the next test would be maybe very hard. If I say, for instance, in the first test,